All right, here is example number 1. We have 4 rotating masses. Let me show you a picture of that. We have in our animation. We have 4 masses of rotating about the z-axis along the xy plane, and we're asked to calculate the rotational kinetic energy of this system. So to calculate the rotational kinetic energy, we use the formula 1/2 I omega squared. All right, where we know that the angular velocity in this problem is given as 6 rads per second, and we're looking for the rotational inertia of the system. We did this problem before, but maybe you have to kind of review it. How do you find the rotational inertia of a point mass? If you recall, it's given by the sum of all the masses, so mi, ri, for all masses. So there are actually really 4 masses. We'll call this 3 kilogram one m1, the 2 kilogram here m2, the bottom left we'll call m3, and the bottom right we're going to call m4. Okay, so we're really going to be summing these, and if you look at it carefully, the distance here, right here, that's really R1, and then over here this is R2, and etc. In fact, you can hopefully note that essentially R1, R2, R3, and R4 are all the same. They're equal to R. Okay, and if you can see that there's a little triangle in here. Okay, maybe I'll erase some of the picture here, but you can see really to find, say, this distance R here. You can see hopefully that this height is 3, it's half of 6, and this length over here is half of 4, which is 2. So R is really, using Pythagorean theorem, 3 squared plus 2 squared, the square root of that actually. So now let's calculate that rotational inertia. You've got like essentially m1, r1 squared, m2, r2 squared, and it keeps going until you get to m4, r4 squared. But all the r's are the same. So essentially I is really equal to m1, m2, m3, m4, and then multiplied by r squared. So that would give you, okay, what do we got for masses? We got 3 and a 2 and another 2 and 4. And then we're going to take the square root of what's 9 squared plus, 3 squared is 9 and 2 squared is 4. So that's 13, root 13, right? But that's going to be squared. So it's really just being multiplied by 13. So that will give you, a rotational inertia of 143 kilograms times meters squared. So now our last step is really just to plug that into here. 1/2, then the rotational inertia is 143, and the angular velocity is 6, and then we will get an answer of, hopefully I haven't made any mistakes, 2,574 joules. Right, and that's it for this example.